Welcome, geometry students. Today we're going to be learning about target 1.3, which is to determine if a triangle is right, acute, or obtuse by its side lengths. If we look at this, we're going to be learning about the converse of the Pythagorean theorem. If you remember earlier in target 1.1, we learned about the Pythagorean theorem. And the Pythagorean theorem, as a reminder, stated that if a triangle is a right triangle, then we can find an unknown side length using a squared plus b squared is equal to c squared. Okay, so that's the Pythagorean theorem as we learned it earlier in the unit. However, now we're looking at the converse. The converse you can think of as a reverse of an if-then statement. Most of our theorems this year are going to be in if-then form, meaning if something occurs, then we can make a certain conclusion. So the if is the what must occur, and the then is the conclusion we can make. So basically, if we look at the Pythagorean theorem, it stated if we have a right triangle, so that was the requirement for that theorem to work, then our conclusion is that a squared plus b squared is equal to c squared. The converse, or like I called before, the reverse, switches the if with a then. Now we're starting with if this occurs, then triangle ABC must be a right triangle. Now at first glance, these two theorems may not look any different to you yet because we're not quite used to the if-then form, but you're going to find that what we need to know about the theorem is going to be different. So your requirements in the if are different, and so that means the way that we'll use the theorem is going to be different. We'll see that in a minute. So if this particular equation is true, then our conclusion is that we have a right triangle. I'm going to go back for a moment here. Now, what if it's a different kind of triangle? For all other triangles, this is true. So if a squared plus b squared isn't equal, but instead is less than c squared, then we know that this particular triangle must be an obtuse triangle. And if a squared plus b squared is greater than c squared, then we know that it must be an acute triangle. So essentially what we're going to use this information for is to determine if a triangle is a right triangle, an obtuse triangle, or an acute triangle. And it all comes down to this symbol here. A squared plus b squared equals c squared makes it right. A squared plus b squared is less than c squared makes it an obtuse triangle. And a squared plus b squared is greater than c squared is an acute triangle. Now if you don't know your inequality symbols, that's going to really affect us here. So going back to a number line, this arrow where the numbers get smaller points to the left, and that's like a less than symbol. I think of it this way. It points to the left, and it's where the numbers are less than the other numbers. So pointing to the left is less than. It also looks like a less than symbol. The other one must then be greater than. So less than is on your left hand, and greater than is on your right hand. All right, let's look at this in action. Tell whether the given triangle is a right triangle. Now before, we would have been given that this was a right triangle, meaning before when we used the Pythagorean theorem, we would know we have a right angle. If you notice here, it does not mark that this is a right angle, so we can't make that assumption. Another difference with this problem is when we were using the Pythagorean theorem in the past, we would have two known side lengths and we'd be finding the third side length. Here we know all three sides, so that's another difference. Well, we're still using the same formula. The difference is how we're using it. We're now using it to decide, is this a right triangle, yes or no? Well, just like before, we had to be careful of the c value. We still have to be careful of the c value, and it has to be the longest side length. Well, looking at this, I don't really know how 3 root 34 compares to 9 and 15. So rather than making the assumption that that's the longest side length, I'm going to plug that in on my calculator and find that that's approximately 17.49. Now that doesn't mean that I'm going to use this approximation when I do my work. It just means that now I can confirm that 17.49 is indeed the longest side length. So I'm going to put that in my c value, but I am going to use the exact simplified radical form they gave me. So a squared is 9 squared plus 15 squared, and we want to know as a question, does that equal 3 root 34 squared? All right, well, let's simplify here. 9 squared is the same as 81, 9 times 9. 15 squared is the same as multiplying 15 by itself, so 225. And then now we have to be really careful of squaring this. So keep in mind, squaring means to multiply it by itself. So we're essentially doing 3 root 34 times 3 root 34. What happens is that 3 times 3 makes 9. Likewise, 3 squared is the same way of looking at that. That's how the 9 came about. But when you square root of 34, what happens is the square root and the square cancel out. So what I'm left with is just plain 34. Now, again, if you look at the expanded form, another way to handle that would be to do square root of 34 times the square root of 34. And that would give you the square root of 1,156. And then we would just go on and simplify this value. And you're going to find that the square root of 1,156 is 34. So we end up in the same result. So if you have questions on this tomorrow, let's talk about that in class. That's some algebra work that we can discuss further. All right, let's continue over here in our equation. 81 plus 225 simplifies to be 306. And again, at this point, we still don't know if those are equal. Well, 9 times 34 also simplifies to be 306. So anytime that a squared plus b squared is equal to c squared, which it is in this case, then that means that, yes, this is a right triangle. So we didn't use the Pythagorean theorem to find an unknown side length. We used it to confirm that this right here is a right angle. So now we can know that that's a right angle, which is going to help us in other future lessons. All right, let's try another example. This one's a little bit more clear to tell which the longest side length is. So we know that this is 26. Still, again, we don't know anything about these angles. We don't even know if we have a right angle. That's what we're trying to determine. So we're going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. Our side lengths, 22 and 14, have to go into the a and b, since they're the shorter of the two, and the longest side length has to go into c. All right, now we're going to simplify. Well, 22 squared is the same as 484. 14 squared is the same as 196. And we want to know, does that equal 26 squared, which simplifies to be 676? Well, if we combine our terms on the left side, we get 680 is equal to 676. Well, in the previous example, we saw 306 is equal to 306. So since a squared plus b squared equaled c squared, that worked out to be a right triangle. These are not equal, so we know that they are not going to form a right triangle. So no, this is not a right triangle. Now, we have not established whether it was acute or obtuse, but we know it is not right, and that's what it was asking us to do, is just to determine whether or not this is a right triangle. So we know that this is not, since Pythagorean theorem did not work out to have a squared plus b squared equal to c squared. They're very, very close, but that does not make it a right triangle. Let's continue on. Example 2 says the segments with lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle. Would the triangle be acute, right, or obtuse? Now, in class, a lot of people have been asking about when we need a picture. And my suggestion is anytime it is useful to you, you should draw a picture. So if you're not sure how to approach a problem, please feel free to draw a picture. If you don't need the picture, then proceed right ahead. But we know that this is a triangle with these three side lengths. The only thing we don't know is anything about the angles. So we don't know whether or not we have a right angle or not. So we're going to use the Pythagorean theorem to determine that. Again, like always, we write the theorem or formula that we're using. And we're going to see if a squared plus b squared is equal to c squared. One thing to be cautious of is what belongs into the c. The c has to be the longest side, so I'm going to use that as the 6.1 feet. So a is 4.3 squared, b is 5.2 squared, and that equals 6.1 squared. Our job is to decide if that really is indeed equal. Well, when we simplify, we have 18.49 added with 27.04, and we want to know, does that equal 6.1 squared or 37.21? Now, if you notice above my equal sign, I keep putting a question mark because we don't know if these two sides are equal to one another. That's really our goal, is to decide if that's true. Well, when you simplify the left side, we end up with 45.53, and we want to know if 45.53 is the same as 37.21. Well, clearly those are not equal, so they are not going to be forming a right triangle. But what we want to go back to is what we have when it's not a right triangle. Well, a squared plus b squared less than c squared, or is a squared plus b squared greater than c squared? If you go back to the very first part of our notes, we talked about this situation and this situation. Now, when it was less than c squared, we said that that would form an obtuse triangle. And when it's greater than c squared, that forms an acute triangle. So I think of it as low, less than c squared is an obtuse triangle. So I just think of low without the w. But keep in mind that's only if your c squared is on the right side of the equation. So if you write it the other way, that won't work. But when we look at this, then really what we have is they're not equal, but we can go further to say that a squared plus b squared is actually larger than c squared. And when that occurs, it's going to form an acute triangle. So we know for sure that not only is this not a right triangle, but we can go on further and use one of these two categories to determine whether it's obtuse or acute. And in this case, it is indeed an acute triangle. All right, well, thanks so much for joining me with Target 1.3. At the end of the week, we're going to be wrapping up this portion of the unit with a quiz. So please come prepared to ask questions tomorrow, and we'll continue to talk about these three targets. Have a great night.